Hello everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we have got Dimitrios who has completed the course ROS2 Navigation and he'll be giving us a presentation on that. So without any further ado, I'm going to hand over the platform to him so he can begin his presentation. Alright, whenever you're ready Dimitrios.
Perfect. Hi everyone. So I'm gonna go through the steps of these packets and that I did after the navigation course. And in my code, I also have like a really nice README code for me. So first of all, we want to launch the simulation. So I'm gonna copy the commands and I can explain them. First of all, we source the environment of the simulation, and then we first of all, no, I'm in the real robot, so I don't need to actually deploy the simulation.
Okay, yeah.
So let's begin with the real robot. We are connected. Let me see that I can control it. Perfect. So let's start first of all from mapping the environment. So I'm gonna launch the cartographer. We can see here it's provided from my package project mapping. I have a really nice launch file where I'm gonna launch basically the cartographer and then RVs to see what's going on. Let's give it a time. Okay. So we can see here the map that is being built from the robot. And I'm gonna start moving the robot slowly around to perform the SLAM algorithm basically. And we're gonna try to map the environment in order to have a clean map for the next steps, which is gonna be localization and navigation. So let's move around a bit. Okay. I'm not good at using the joystick, but fine.
You could use Tilo if you don't mind.
Yeah, I could. Do you want me to?
No worries, whichever one will get us through as quick as possible so that we don't run out of time.
Yeah, I think that's fine. Okay, I think that's a clean map for now. So I'm gonna have to save the map. So I'm going back to my cheat sheet. We can see we have the map saved.
We
Yeah.
cannot see your screen, Dimitrios. I think you stopped sharing.
Okay. Let me start again. Is it okay?
Yeah, you can. Okay, now we can.
Okay.
It's loading. Let's see.
Okay, so we have a clean map at this point.
Yeah, now it's visible.
And okay, so I'm gonna save the map and I'm gonna use the map saver from nav2map server, which is this command here. So I'm gonna run basically this server, and I'm gonna specify this specific this directory. Let me go inside my workspace first. Perfect. So yeah. So it's gonna save under the name sim world. I actually want to name it real world because I'm not in the simulation. So, okay, perfect. I saved my map at this point, and we can move in the next step, which is actually localization. I'm gonna stop the cartographer. Perfect. So let's go inside. Okay. So for the localization, again, I have to deploy one of my launch files. Let me do a calculation bit. No, I think I have done it already. But let me source my setup. Okay. So, so I have a project localization package, which I included a localization launch file, where I have to just specify the map that I just built, which I call real world. Let's launch this. For the localization, I can provide an estimation for the location of the robot, and hopefully then it's going to be fine. So wait, this actually didn't build. So let me try again this one. Build. Okay, great. I'm not having a map. And I cannot wait. Let me see first the error message. Yeah, I missed it. Yeah. So I made a mistake here. It's real world, and I have to specify the file, not just the name.
Okay, all right.
So hopefully that's going to be okay. So that's going to be fine. So as I said, we can provide an estimate of the location of the robot, which I think, if I'm not mistaken, is this one. Let me see. Okay. Then if we move the robot a bit, yeah, the localization, it's going to get better and better. I think one full turn is going to make the localization way better. And of course, we can do like more autonomous things, like actually deploying the randomizer where the initialize global localization. I can do it if you want. Basically, I'm going to provide random position for the estimations of the location of the robot. We can see the map, and then we just have to navigate around in order to eliminate some of these estimations.
Can you explain what's the difference between that method and the one that you're just using?
Yeah, so the previous one, I provided a higher logic. I knew where the robot was, so I provided an initial localization. So around this area, we try to find the best estimation. But the other one, it's completely random. We have no prior knowledge of where the robot is. So we fill them up with random positions, and then we try to eliminate the ones that are not needed. So what changed basically is the prior knowledge of the robot's estimate of the location. So we can see with a full rotation, maybe just some movements. It's still not really good localized, but we can get it there if we have the time. Let's go a bit. Yeah, I think it's in the opposite. So now it's actually localized. It took some time, but
are you using the same YAML file for simulation and for the real robot?
Yeah, it's the same one.
Okay, so there's something going on there. So you can see that I think you stopped sharing one more time. Can you refer back? Can you share again your screen?
Sorry, Mel.
Yeah,
sorry. I don't know what's going with this, but yeah.
I think maybe it stops when you click a different screen. But anyway, no worries. So I would say, you see, your map is moving around like that. I think there's a parameter that's not set correctly. So
yeah, that's true. That's for the simulation. It's for the laser scan. And for some reason it saves all the past laser scans and not just the current one. But yeah, I didn't actually pay attention to this. In the simulation, it works better, and I can see a transform there. But yeah.
Okay, so we can check this later, but I think maybe your sim variable is set to true and you're using the real robot. But anyway, no worries. So
yeah.
What we want to do is, can you show us how it can successfully navigate to a certain waypoint? So let's go through with it.
Yes, so let's go to this one. So first of all, we have to define some waypoints, and we're going to use this launch file here. So again, I have to set correct the map real forward YAML. Okay, so this is again a launch file I created. It launched a custom node where we can specify on the map some points, and we can see how it's done. If the RVS opens.
Yeah, let's give it some time. I think it will load soon. Since it's our first time. No, actually.
Okay, so it's easy. I can pick some points on this map, and these are going to stay. So I'm going to pick this one. And we can see, if we can distinguish from all of this mess that's going on here, we can see it's saved in this directory here. I can go to this directory. Let me save some other points first, and we can see the directory there. So this is the second waypoint, and this is the third one, let's say. And if I go to the nav2 project and points, I have this file and where all the points have been saved. I can add a fourth one just to see the change on the file. So we can see the fourth one here. I can change these names. This is basically the ID of this point, but for now I think I'll leave it like this.
Wonderful.
So let's go to the actual navigation for these points. So again, my tsitsi, the README file, I have the path planning here. So we just want to launch the full stack of nav2 now. We, of course, localization and also navigation now. So I can specify the map. Okay. Nice. So as before, we have to start with localization. I have to specify, just for the time being, an estimate of where we are. So I think we are closely here. Okay, I'm going to do a full rotation just to have a clean localization at the beginning, just to make sure. Yeah, I think now it's fine. Great. And first of all, I can test it with just setting a goal in our vase. So I could set a goal for the robot to go there. I have decreased a bit the speed, but still, it's kind of jerky. And let's actually launch a specific waypoint. So I have a custom node called go to pose. See the command before, right? So it's the go to pose node, and I have to specify the spot list I saw you before and the name of the point I want to go. I actually don't remember which is the point one, but let's actually see it. So yeah, it was in that corner. So the goal is accepted, the robot tried to go there.
And we can also see the path. Okay, very nice.
And navigation succeed. And with the same way, I can go to point 2. So what's the other one? Yeah. The laser scan here, it's awful.
Yeah, we should check that variable that we spoke about earlier. But afterwards, yeah.
Yeah, so that was it for the real robot, I guess. That's the full project.
All right, let's see how it would look in simulation since we still have a bit of time.
Okay, so that I just disconnect with the robot, right?
Yes.
Perfect.
And remember to share one more time once you're done.
Yeah. Okay. Can you see my screen?
Yes.
For some reason, like an hour ago, the code editor doesn't appear, but I have opened it here on a different page, so that's fine.
Okay.
Okay, so let's go again to opening this time the simulation, pushing the right packets and launching the turtle. Great. And I think I also deleted the simulation map, so that's good. We have to do it again.
Okay, all right.
So, okay. It's my workspace. Let me do a Google just to make sure. Yeah, it shouldn't take that much time, but okay. So perfect. Let's launch the cartographer again. And this time we don't have a joystick, so I'm gonna launch again the teleop twist keyboard. So yeah, you can see the cost map and everything here. It's kind of cleaner. Not the cost map, but the map building. Okay. So let me just decrease a bit the speed. And then ZX. Okay. So I'm starting moving the robot. You can see the map being built here. Across. Okay. Let's back up a bit. I think that's quite fine for now.
Yeah, it looks really clean.
Okay, so I'm stopping this. So again, let's save them up. This time the sim word is the correct name. Okay, I'm opening a different window, terminal. Okay. Okay, so now I'm saving the map that we created. Perfect, and we can use it now. So I'm gonna close this window. I'm gonna keep the navigation. I can move it, but that's fine. And maybe I'm gonna keep this one. You never know. So should we jump to the path planning, which has also the localization?
Yes, let's skip to that. Yes.
Okay. So again, I'm opening this one, and it is the same word. Yes, perfect. Yeah, man. Okay, so again, I have to provide an initial estimation of the location of the robot. Let me change a bit the perspective. Okay, that's nice. So I think the robot is in this location and facing this direction. Yeah, that's somewhere correct. I'm gonna do again a full turn just to localize it better. And we can see it says, you can see the cost map here, and the laser scan appears cleaner. So yeah, I have to maybe configure the real robot.
Yeah, so
in a different
the YAML file, yeah, maybe you need a different one depending on if you don't want to change the parameters for each case.
And that's fine. We are in good we are localized at this point. Great. I'm gonna stop this. I'm gonna give it a go from the RVs for now. So we can see a clear navigation, and we can do again, if we have time, the path plan with the waypoints. So basically I have to launch this one. Oh, I should have launched this before this.
No worries. Anyways, I was about to shift to questions. So
okay, perfect.
Yeah. So I think every time you switch screen, your screen stops sharing. But no worries. We have seen the demonstration
again.
Yeah, don't worry about it. What I want to know is, so let's talk a bit more about what's going on there, right? So, first of all, what would be, so this is a question that would maybe trigger you to maybe think a bit more in detail about the mapping stuff, so, and the localization as well. So what would happen if the building was symmetrical, right? In terms of localization, what would be the effect of a perfectly symmetrical environment to the robot? And
I think that's
Can you explain why? Yes.
Yeah, of course. I mean, this building is kind of symmetrical, and we saw that when I did the random initialization. We saw like two main points that the robot thought it was. So it was in the right corner and the left, down corner,
Yeah.
because all the features that you have are exactly the same in both corners.
Yeah.
So I think that's a bigger problem. So we need to have some different features in the space in order to distinguish if I'm in the right or the left corner,
Right.
basically.
Very true. Yeah. Very true. All right. All right. And the other thing that I wanted to ask you about is, so let's talk a bit more about global and local cost maps, right? So clearly they have different roles, that's why they're there, but can you explain in more detail how each one of them is established? Let's.
Of course. So, I mean, they're different, but they do the same thing about path planning. So, the global path planning and the global cost map initialize a global path. So, from start to end, what is the expected path that we're going to take? The local map takes into account dynamic objects that might appear, changes in the environment from the map that we already have. So basically, the global cost map is a full map that is static and changed, and it's there for the full path. And the local plan is for avoiding new stuff that might have been added to the space and redirecting the global path in order to achieve the goal. So the way I see it is the local cost is more about dynamic objects, and the global social ones.
Right.
They also have like different use cases.
Right. Yes, very well explained. I like the fact that you brought down the local cost map to something more about dynamic obstacles rather than following the proper global path that has been established with the first try. Right. So that's very. That's basically the fundamental way of explaining it, right? So the reason why we have it there is so that we can have our robot be able to deal with things that appear that were not planned for in the first place. All right.
Exactly.
All right. So one last thing. So let me check my list of questions here. Okay. So talk us through the process of convergence. So we saw that every time you try to localize your robot for the first time, you had to do something, either move it around to make sure the particles cluster together, right? So can you tell us what does it mean to say the particles have clustered together in terms of the mathematical stuff that's going on behind the process of that?
Yeah, of course. So first of all, we can see these green arrows here in the RVs. If you can see my screen,
Yes.
can
We
you see it?
Yep.
So basically, we call particles that are spread around in the world, and these are estimated in the orientation of robots. Each one of them has a confident level of how sure they are the robot is at this position.
Yes.
If you have this, the actual estimation we have is the sum of all of these particles. So we can see it converges in the middle of this cluster because that's the point where it's drawn to. And every time we move to, we move forward or we do a rotation, that's also like a parameter that we can configure when it's updated. We see again the environment and we compare it based on the estimation. So these particles move based on the odometry, let's say, and in the new place they end up, they update their confidence on if they're correct or not. If they meet a threshold, they are deleted from the stack. And also new points are spawned, are created board randomly in order to have also other estimations.
Very
So
nice.
I think that's a general idea without going to details, but yeah.
Very, very nice. I like that that approach. Very, very nice. Thank you very much, Dimitrios. It was a nice presentation, and I do quite like the way you explain in detail about how the nav stack is working and these particular details, because we can get it to work, but what's more fundamentally important is to understand how it's working so that we can tune it appropriately. So very well done.
Thank you, really appreciate it. Thank you also for the course and your time.
Hang around, we'll finalize. right, everyone. This was Dimitrios' presentation, and very warm congratulations to him. And I'd like to encourage all those of you who would want to try this course to do so as well. And then you can also come and showcase your work the same way Dimitrios has done. So one more time, congratulations to him, and very nice work. All right.